Okay, so I promised to make a video about today's lesson, Introduction to Inverse Trig, and so here it is. I'm going to do it a little bit differently because there's a little bit of subtlety and it's a little bit difficult to do everything from scratch. So I already have the notes done, at least the first 3 pages, and I'm going to talk you through them. And what I think you ought to do is take a second to pause the video whenever you need to write things or shade things or just process things, whatever you want to do. So for beginning, I would like to just kind of throw out a warning. The inverse trig is really going to test you. It's maybe one of the most difficult things we do all year. That's not to scare you, but you have to give it a good go. You have to put some time into it. You have to ask questions. You have to not just pretend that those moments where you're confused will just correct themselves by divine intervention. It's going to be up to you to really stick with it. So, having said all of that, here we are on page, I believe it's the first page in the light blue packet. And we're starting out right up here with this particular graph, and it's a sine graph, you can tell, because it's, from the origin here, it's middle, up, middle, down, middle. And I did add a few of the values on the x-axis in order to help me with what we have to do down here. So, right in between negative 2 pi and pi, you need a negative 3 pi over 2. Between negative pi and 0, you need a negative pi over 2. And then between 0 and pi, you need a pi over 2. And then between pi and 2 pi, you need a 3 pi over 2. So if you need to add those, pause the video and do that. And I'm just going to keep talking. So the first thing it asks you is, what does the horizontal line test tell us about the sine function? Well, if we just come up here and put a horizontal line through this, everything, it's going to cross this particular graph in many, many places. So it's failing the horizontal line test. What that tells you is that if you go to invert this thing, the inverse will not be a function. It will be a relation, but it will not be a function. All right, so that implies that we will have to restrict the domain in this particular graph in order that we can have a function in the graph that we produce for the inverse. And remember, inverses switch x and y. So what do the x and y represent? Well, x is angles. So we input angles, and then we do sine of that angle, and that'll produce a ratio, anything from -1 to +1. All right, so that's what that represents, and we'll come back to this particular little shaded in area in a second. So let's come down here, and you can see that I made x-y pairs for the original, for this original graph. So when x is negative 2 pi, y is 0. When x is negative 3 pi over 2, y is 1, right up here. When x is negative pi, you're back down to 0, and it just keeps doing that. So you may want to pause the video and complete this. Once you've completed it, you will then, although you'll keep the column labels the same, the inverse is going to switch x and y. So you see how y is 0 here, but it's in the x column over here. So just switch all of those, and then we'll just discuss what to do after that. So copy down the 2 tables and just pause. All right, so now that you have copied those down, we are going to use this second table right here. Whoops, get rid of that. This table right here to build this graph. So here are all your ordered pairs. So when x is 0, y is negative 2 pi. And when x is 1, y is negative 3 pi over 2. It's not shown there, but that's what it is. All right. When x is 0, y is going to be negative pi, and so on. And you can see it's going to kind of go middle, high, middle, low, middle, high, middle, low, middle, high. All right. So you can go ahead and copy that down if you need to. Pause and make sure you connect it so now it's snaking on the y-axis instead of the x-axis. So go ahead and copy. All right, so keep in mind that this is no longer angles that you're inputting. You're inputting ratios. Like this will be sine theta. And now your y-axis will be theta. Okay? Well, what you're going to notice right away is that this fails the vertical line test. See? It's failing it pretty badly. So we're going to have to restrict the original domain, which will then become a restriction in the range of your inverse graph. All right. So wise people in math decided, let's put this around 0. All right. So they broke it off at negative pi over 2. And you notice this is not a dashed line. So we're actually including negative pi over 2. And then they made another line at pi over 2. And they restricted the domain to those two values and everything in between. So go ahead and draw that and shade it. And what we're just going to do is discard everything to the left of that region and everything to the right of it. Okay? So go ahead and do that and shade it and pause the video. All right, now that you're back, we are going to now go ahead and reflect those sort of values that are creating like this interval. And so we'll draw them going through negative pi over 2 below this x-axis and positive pi over 2 in this above the x-axis. And shading in between is going to create something that if we discard everything above, everything below, will pass the vertical line test. Now, when we first had it, this is not a function, but after you restrict the range, which is low to high, we now do have a function. So go ahead and do that, and then check back in. All right, so now that you're back in, we are going with the inverse of sine, and that's where x and y swap places. And this is just the notation for it. You can have y equals sine inverse x, or y equals arc sine of x. I believe that arc sine of x is a little bit more, I don't know, archaic, a little older, but all textbooks pretty much have both. So ours does too. So you're just responsible for knowing that those two things mean the same. All right? So now that we've done this, we're going to isolate both of those two, first the restricted domain and then the restricted range. All right? So then you come over here, and we can go ahead and at negative pi over 2, we're at negative 1. At 0 here, we're at 0 here, 0, 0. And then at pi over 2, we're up to 1. And then there's nothing else to either side. Remember, this is input angles, output sine ratios. So this is just that little piece, has the same little curvature as it does over here. So go ahead and copy this down. And this should be solid lines because we do include the negative pi over 2 and the pi over 2. And that becomes our domain. All right? So that is the domain for our restricted function. And the range is negative 1 to 1. All right? So go ahead and copy that and then come back. All right, now that you're back, we're just going to go ahead and do the inverse of this, which will be really this piece right here that I'm kind of drawing with this little cursor. And remember now that your sine theta is here, so this is ratios, and the output is angles. So that's the whole thing. We're trying to take ratios to angles. So if you come over here, when x is negative 1, y is going to be negative pi over 2, that's here, and then you have the origin marked, and then you have when x is 1, y is pi over 2. So that's it. And of course, as I said before, that'll pass the vertical line test. And then what we can do for the bottom is that this range is the domain down here. And similarly, this domain is now the range down here. What we're doing is we are actually simulating what graphing calculators do. So, yeah. Now the issue here is when we have outputs, we can only have outputs from negative pi over 2 to pi over 2. That is going to create some issues. So, well, we will deal with the issues. All right, let me kind of clean up all of this. And just you can pause and clean and look this over and fix up any kind of things that you have remaining with your notes. And I am going to take this time to pause and switch papers. See, it's as if no time passed at all. So now we're on the next page, which I believe is page 2. We're going to do pretty much the same thing with cosine. Remember, this is your basic cosine function: high, middle, low, middle, high, 2 periods. And remember, we're inputting angles and outputting ratios. So we're just going to go and, oh, and I also filled in these missing values because they're skipping values at these marks. So in between negative 2 pi, negative pi, negative 3 pi over 2, and between negative pi and 0 is negative pi over 2. Then here's pi over 2, then here's 3 pi over 2. So put those in, and then you can pause, or pause and put them in, whatever. And we're just going to go ahead and list all of these kind of anchor points, and then we're going to flip them over. So again, negative pi over 2 and 1, negative 3 pi over 2 and 0, negative pi and negative 1, negative pi and 0, 0 and 1. That's where all these numbers are coming from. After you put all those in, go ahead and switch the order, because this is going to be our given function and this is going to be the inverse. All right, and remember, this is going to fail the horizontal line test just like sine did. All right, so go ahead and do that, and pause the video. All right, assuming now that you've done all of this, we can now graph the inverse. All right, so at 1 we can go down to negative 2 pi. At 0 we can go down to negative pi, 3 pi over 2. At negative 1 we can go to negative pi, and you can see it's just going to do what it did before: high, middle, low, middle, high, middle, low, middle, high. So go ahead and do that and create the snake around the y-axis. And remember, now the x-axis is ratios and the y-axis is angles. So do that and come back. All right, now that you're back, the one thing I don't have on here, they want to know if what we came up with was a function, and that's a big no because of it failing the vertical line test. So what we have to do again is restrict the domain of the original, and mathematicians do that from 0 to pi inclusive. So that's why I've got a vertical line here and another vertical line here, and I shaded everything in between. And so everything to the left of it, to the right of it, is not there anymore. So go ahead and do that. All right, now that you've done that, come on back, and we're going to do the same thing. We're just going to reflect this shaded region from 0 to pi this way. All right, and that'll shade in. And what that's going to do is create a piece that will not fail the vertical line test, and that's going to be the restricted range that we got from this restricted domain. All right, so do all your artwork and then come back, pause. All right, now that you're back, we have notation for it, and it's this right here. All right, so we can use y is cosine inverse of x, or y equals arc cosine x. Really doesn't matter, they mean the same thing. All right, so now what we're going to do is we're going to focus in on isolating these parts of these functions that we're going to actually put into use. All right? So here, we're only doing from 0 to pi, and you start out 0 and 1, and then pi over 2 and 0, and then pi and negative 1. That's going to set up a domain of 0 to pi, and it's going to set up a range of negative 1 to 1. So go ahead and do that, and then come back. All right, now that you're back, we're going to do the same thing with this piece. Remember, all the other, we discarded everything else except what's in the shaded region. So when x is a ratio of 1, y is pi. See, 1 and pi. And then at 0, we have pi over 2. And then when x is 1, y is going to be 0, right? So what's going to happen, and we can write this in, the domain is going to become the range in the inverse. And then the range is going to become the domain in the inverse. All right? And the graphing calculators will give us values from 0 to pi. So we're emulating a graphing calculator. All right? So what I want you to do is take a little bit of time to complete the notes on this. Pause it, and while you're pausing, I am going to go ahead and go to the 3rd page. And we're back. Seemed like no time passed at all. So we're on page 3, and if there's anything remaining from the first 2 pages that you need to copy down or process, just go back in the video and fill in whatever you missed. All right, you see we have a lot of periods here. And clearly, this guy is not going to pass the horizontal line test. See? Nope. It fails it pretty badly, all right? So we're going to have to restrict the domain, and this is going to be a lot simpler than the other two. Mathematicians have just chosen between negative pi over 2 and positive pi over 2. Now look and see, these asymptotes did not become solid, right? So those values, when you put them into your range, are still going to be dashed, which means we're not including them. Those are just asymptotes. So pi over 2, negative pi over 2 will not be part of our range. We're going to approach them, but we're not going to include them. All right, so for regular tangent, of course, you should pause if you need to do the shading here. And of course, we're going to discard everything right and left. Remember the domain, you just took a test on this, is all reals, but x cannot be pi over 2 plus n pi, where n is the element of z. That's for the whole thing, right? Once we restrict it, we're going to change that to just negative pi over 2 to pi over 2, period. So that when you change that from domain to range, that's what we're going to have down here, all right? And the range is negative to positive infinity. That will stay the domain because that stretches forever to the right and that stretches forever to the left. So you can see this thing is now reflected, and we're not going to build a bunch of points or anything, but we write it tangent inverse, and you can say arctan if you want, x. The domain will be what the range was before, right? So here's the range from the original. That becomes the domain for the reflected. And you will have to change this domain once you get it into range to only be from negative pi over 2 to pi over 2. So it's almost like sine inverse, but we're not including these two n values, all right? Graphing calculators will give us from negative pi over 2 to pi over 2, and it's very seldom that you have anything that would fall on the asymptote. I don't think I've ever seen it, right? So go ahead and copy down anything that you need, and I hope that that's enough explanation. Just clean off all of this stuff. And while you're doing that, just go ahead and pause, and I'm going to switch over to page 4, which is actually your page 5. My 4th page, but your page 5. So bear with me. I'm going to go ahead and pause.